At dawn on March 12, 1943, the shipyard at Richmond, California, rumbled like a living beast. Sparks flew from 1,000 torches. The air shimmered with the metallic scream of grinders and the rhythmic clang of steel plates being welded together. In a haze of smoke and salt mist, the hull of a new ship rose from nothing, a steel giant that would soon race across the Pacific. But hidden beneath the roar of labor and machinery was a secret so bizarre, so unconventional, that even veteran shipbuilders laughed when they first heard it. The idea that a ridiculous new welding trick could replace the centuries-old art of riveting and do it faster than anyone thought possible. U.S. Maritime Commission Production Log Mar 1943. For decades, shipbuilding had been an orchestra of hammers and rivets. Thousands of men worked in synchronized rhythm, driving red-hot bolts through steel seams. It was slow, dangerous, and deafening. Riveters were artisans, proud, scarred, and skeptical of change. But in 1941, as America raced to prepare for war, the old ways couldn't keep up. German U-boats were sinking Allied tonnage faster than it could be replaced. The Atlantic ran red with fire and oil. Britain cried for help. President Franklin D. Roosevelt responded with an impossible challenge: build ships faster than the enemy could destroy them. White House press release, Jan 1942. The U.S. Maritime Commission called for a revolution, not just in quantity but in method. Traditional shipyards scoffed. Welding was still experimental for hull construction. It was thought to weaken steel, create cracks, and collapse under stress. It's suicide to weld a ship together, one foreman sneered, according to yard records. Kaiser Archives, 1942. But a few engineers refused to listen. They believed that if welding could be mastered, it could cut shipbuilding time by more than half. Among them was a construction magnate named Henry J. Kaiser, a man with no shipbuilding experience, but an obsession with efficiency. He called it industrial war. Kaiser's shipyards in Richmond and Portland became laboratories of speed. He brought in automotive engineers, pipeline welders, and metallurgists to design a new process. Instead of bolts, molten metal would fuse plates together, turning entire hull sections into single units of strength. The trick, derided by old-timers as ridiculous, was to preheat plates with torches and layer weld seams in a pattern that distributed stress like a spiderweb rather than a line. The result was lighter, stronger, and far faster to assemble. Technical Bulletin number 312, U.S. Maritime Commission, 1943. The change was immediate and shocking. Where a riveted Liberty ship once took 8 months to complete, a welded Victory ship could be built in a fraction of that time. At peak, Kaiser's yards were turning out ships in less than 45 days, some in under 2 weeks. On November 12, 1942, the SS Robert E. Peary was launched just 4 days and 15 hours after its keel was laid, a feat the press called a miracle of molten steel. San Francisco Chronicle, Nov. 1942. To the men who had called it madness, the sound of welders hissing through the night now meant victory. But this new speed came at a price. Early welded hulls cracked under the pressure of the cold Atlantic. Ships broke in half without warning. Investigations found brittle fractures spreading like lightning through the weld seams. Engineers scrambled for answers. The cause wasn't the welding itself, it was the steel. Wartime shortages forced mills to use lower-grade materials that turned brittle in freezing water. The ridiculous trick became a national embarrassment overnight. Newspapers mocked the ships that snapped like matchsticks. U.S. Navy Damage Report 1943. Inside Kaiser's offices, panic turned to determination. Metallurgists from the University of California and the Bureau of Ships studied thousands of fractures under microscopes. They discovered that the welding technique itself, and when done correctly, actually strengthened the hulls. The problem lay in the steel composition and temperature control. By altering the carbon content and introducing preheating procedures, the welded seams could flex rather than snap. Bureau of Ships Metallurgical Report, 1943. The ridiculous trick was not to abandon welding, but to master it. At Richmond Yard No. 2, women welders, known as Wendy the Welders, became the unsung heroes of this transformation. They worked in shifts around the clock, their faces hidden behind heavy masks, their gloves blackened by sparks. Many had never held a tool before the war, yet within weeks they were welding hulls that would survive typhoons and torpedoes. One worker recalled, "They told us we were doing a man's job. We told them we were doing it faster." Oral history. Collection Rosie the Riveter Trust. By late 1943, the new welding method had been perfected. Ships rolled off the ways at unprecedented speed, each one sleeker, faster, and deadlier than its predecessors. The Victory ship class, designed to replace the older Liberty models, featured longer hulls, turbine engines capable of 17 knots, and stronger, all-welded frames that could handle heavier loads. Engineers credited the preheat layer welding sequence for distributing stress evenly along the keel. Engineering Division Report, 1943. What began as a ridiculous experiment had turned into a doctrine of industrial warfare. Across the ocean, German intelligence reports were astonished. How could American shipyards outproduce the entire Axis Navy? One captured officer described the effect as industrial witchcraft, captured Kriegsmarine interrogation, 1944. To the Nazis, whose production was crippled by resource shortages and labor bottlenecks, the idea of modular welded construction seemed alien. In truth, it was born not from genius alone, but from desperation and the courage to trust machines and people in new ways. By 1944, the welding revolution had changed everything. The U.S. merchant fleet grew so rapidly that convoys now outnumbered the submarines hunting them. Supplies flowed relentlessly to Europe, Africa, and the Pacific. Fuel, tanks, rations, ammunition, all carried aboard the welded ships that no one thought could survive. Each one was a monument to speed, ingenuity, and defiance. Each weld seam carried the sweat of men and women who refused to surrender to tradition. Yet as the war's tide turned, a new question emerged among Allied engineers and commanders. If welding could reshape shipbuilding, what else could it transform? Airplanes, tanks, even bridges, all could be built faster, lighter, stronger. The implications rippled across the entire Allied war machine. The welding torch was no longer just a tool, it was a weapon. But deep in the frigid waters of the North Atlantic, another battle was unfolding, one that would test whether these welded ships could truly endure the unforgiving seas and the fury of German torpedoes. The answer would come in fire and steel as the first welded convoys sailed into the storm. Royal Navy Convoy Report, Jan 1944. By early 1944, the secret was no longer rumor, it was revolution. America's shipyards had unlocked the hidden advantage that would flood the seas with steel. The welding process, once dismissed as dangerous alchemy, was now codified in technical manuals and spread through every major yard in the nation. The ridiculous trick had a name: preheat sequenced flux welding, a method so simple in appearance that visiting officers from Britain and Canada thought it must be a hoax. Yet the results spoke louder than theory. Technical Manual TM 9294, 1943. The process began with a controlled preheat of each steel plate before joining. Welders used acetylene torches to raise the temperature to around 300 becquerels, just enough to reduce brittleness and prevent microcracks. The seams were then fused using a low-hydrogen electrode, with welders moving in alternating patterns across the hull's surface. It looked chaotic, but the pattern was meticulously engineered to distribute stress and avoid warping. Engineers. From the Bureau of Ships compared the effect to knitting steel into cloth. Bureau of Ships Report 1944. Each Victory ship required nearly 1.2 million feet of weld seams, about 230 miles of continuous molten metal. At the Kaiser yards, welding teams worked in rotating 12-hour shifts, their torches lighting the night like constellations over the bay. The trick's real power lay not in the welds themselves, but in how they enabled modular construction. Instead of building ships piece by piece, engineers divided them into prefabricated sections: bow, stern, deck, and engine room, each built simultaneously in different parts of the yard. When finished, giant cranes lifted the sections into place, the welders sealing them like puzzle pieces in a matter of hours. U.S. Maritime Commission Production Memo, 1944. At the heart of this transformation were the engineers who turned chaos into order. Metallurgist Dr. Constance Tipper of Cambridge University, working with American counterparts, proved that brittle fractures were a result of steel composition, not welding itself. Her research led to the adoption of higher manganese content steels, which retained ductility in cold water. Tipper Report, 1943. Meanwhile, welding foreman Leo Smigel at Richmond pioneered the flux-cored electrode that stabilized the molten pool, allowing unskilled laborers to produce near-perfect seams after just weeks of training. These breakthroughs meant anyone, farmers, housewives, students, could join the industrial army. But the ultimate test came not in the lab, but at sea. In May 1944, convoy HX-290 departed Halifax bound for Liverpool. Among the 20 merchant vessels was the brand-new SS Pierre Victory, launched only 35 days earlier. Its hull gleamed under grey Atlantic skies, a sleek welded body without a single rivet. The ship carried 10,000 tons of ammunition, enough to arm an army. The crew knew the risks. German U-boats still prowled the depths, and welded ships had yet to face a full attack. Royal Navy Convoy Report, May 1944. On the third night at 02:17 hours, sonar detected movement. The convoy zigzagged under blackout conditions, phosphorescent trails flickering in the waves. Then out of the darkness came a torpedo. It struck the SS Pierre Victory on her port quarter with a thunderous blast. The sea erupted in flame. For a moment, the bridge crew feared the hull would split clean in two as the old Liberty ships had done months earlier. But the welded seams held. Instead of shattering, the energy rippled through the hull, deforming but not breaking. Within minutes, damage control crews sealed the wound with steel patches. The ship stayed afloat and limped to port, her decks scorched but intact. U.S. Navy After Action Report, 1944. That night became legend among shipbuilders. The Pierre Victory's survival proved that the new welding method worked, not just in theory but in battle. A British engineer aboard a nearby escort wrote in his diary, "Dramatized. The Americans have found a way to make their ships breathe instead of break." Royal Navy Officer Diary, 1944. The ridiculous trick had crossed the line from experiment to weapon. Back in the shipyards, production exploded. The Welding Control Division at Kaiser implemented new quality standards: X-ray inspection of seams, temperature tracking, and layered supervision. Over 50,000 welders were certified under the new protocols. Each received a small brass tag stamped with an identification number, welded onto the ships they helped build. Those tags still lie at the bottom of the ocean on hundreds of wrecks, a silent signature of America's industrial might. Kaiser Welding Division Records, 1944. Technically, the Victory ships were marvels of mid-century engineering. Measuring 455 feet long with a 62-foot beam, they displaced 50,200 tons fully loaded and could reach 17 knots, 5 faster than the older Liberty models. Their turbine engines, designed by General Electric, produced 6,000 horsepower. Every major component, from propeller shafts to bridge structures, was welded rather than riveted, reducing total weight by nearly 1,000 tons. This made them faster and more fuel-efficient, capable of outrunning U-boats in some cases. Engineering specifications, Victory Class 1944. German intelligence, analyzing wreckage from sunken ships, initially dismissed the welding revolution as propaganda. But by late 1944, captured documents from the Reich's Naval Construction Bureau revealed growing alarm. "The Americans build ships like sausages," one report complained. "They do not repair, they replace." Captured Kriegsmarine Memo. Nov 1944. Axis industry, constrained by shortages of skilled riveters and alloy steel, simply couldn't match the modular pace of Allied welding production. The human dimension was just as critical. Women and minority workers, previously excluded from heavy industry, became essential. In Richmond alone, 30% of welders were women, many trained by instructors from General Electric's welding school. Among them was Lola Weisenfeld, a 22-year-old from Iowa, who set a production record for completing 312 linear feet of flawless hull weld in one shift. Her name appeared in the Yard newsletter beside the headline, "The Best Welders Don't Wear Ties," Richmond Shipyard Bulletin, 1944. Engineers also pushed the boundaries of automation. Early arc guidance machines using electromagnetic sensors allowed consistent seam tracking along curved hulls. These semi-automatic welders, precursors to modern robotics, tripled efficiency. Henry Kaiser famously called them mechanical welders that never sleep. U.S. Maritime Commission Technical Symposium, 44. The rhythm of shipbuilding became mechanical poetry. Cranes swinging, plates slamming, torches hissing in unison. By late 1944, the Allies had produced more than 2,110 Liberty ships and 531 Victory ships, most fully welded. The United States had achieved something unprecedented, an industrial tempo that turned logistics into a weapon of war. Every day a new welded hull slid into the water, its bow christened with champagne, its seams glinting in the sun. U.S. Warshipping Administration, 1945. Behind each launch stood welders who knew that every bead of molten metal could carry soldiers, tanks and food across oceans. Still doubts lingered among naval architects. Would these welded giants endure the freezing North Atlantic and the relentless pounding of heavy seas over months? Could mass production maintain the precision needed for survival? The next major test would come in one of the coldest winters of the war, when an entire convoy of welded ships sailed through Arctic waters toward Murmansk under constant Luftwaffe attack. There, the ridiculous trick would face nature itself and determine whether speed and innovation could truly conquer steel fatigue, ice, and war. Allied convoy records, Deck 1944. The Arctic convoys were hell on steel. The air burned the lungs, the decks froze to glass, and the waves struck like hammer blows. In December 1944, convoy JW-62 crept through a blizzard toward Murmansk. Among its escorting freighters were 3 newly built welded Victory ships, the SS Morton M. McCarver, SS Wabash Victory, and SS Pratt Victory. Each carried thousands of tons of munitions and supplies for the Soviet front. Temperatures dropped below 30 degrees Celsius. Riveted hulls groaned and leaked, their joints rigid with ice. But the welded ships, those ridiculous experiments, flexed and bent with the waves. Steel that once would have cracked under such stress rippled instead, alive and resilient. Royal Navy Arctic Report, 1944. When German aircraft attacked near the Kola Inlet, the convoy scattered through fog and sleet. Bombs splashed near the McCarver, sending shockwaves that lifted her bow clear of the sea. For minutes, crews waited for the sickening crack of steel. None came. Her welded seams held, even as riveted escorts nearby buckled under the strain. Engineers later wrote that her survival validated the welder's torch more than 100 laboratory tests. U.S. Navy Damage Survey, Jan 1945. From that moment, the argument was over. Welding was no longer a gamble. It was doctrine. The impact rippled far beyond shipyards. Allied commanders realized they were witnessing an industrial metamorphosis. The welding trick had transformed the war's logistics. Cargo ships launched faster, sailed farther, and burned less fuel. In 1943, the average cargo vessel took 230 days to complete. By mid-1945, Kaiser's yards could deliver a welded Victory in under 40. U.S. Maritime Commission, 1945. This production speed turned supply into strategy. Every division landing in Normandy, every tank rolling through France, and every bomber fueled in Italy owed its existence to the welding torches that glowed through America's nights. Psychologically, the effect was profound. Workers at Richmond and Portland felt they were fighting their own frontline war. "Our battlefield was the blueprint," one supervisor said. "Every ship we finished was another bullet for democracy." Rosie the Riveter Oral History, 1945. Welders kept photographs of convoys on their lockers, tracking ships they'd helped build. When telegrams arrived confirming a welded ship's survival after attack, production crews cheered as if they'd sunk a U-boat themselves. The bond between labor and battle had never been tighter. For the Axis, the revelation was crushing. German naval architects interrogated after the war confessed disbelief at the pace of Allied production. "We could not understand how America replaced ships faster than we could sink them," one officer admitted. "We fought an enemy of steel and fire, not men." U.S. Strategic Bombing Survey, 1946. The psychological blow extended to Hitler himself. Reports from late 1944 describe his fury at Allied ship output, surpassing the entire Axis total. To him, welding symbolized the industrial war he could no longer win. Bundesarchiv, Führer Conference Notes, 1944. Behind that steel miracle stood an invisible army, the engineers, metallurgists, and inventors who perfected the craft. In Detroit, automotive specialist Eugene Hodry developed the gas mixtures that stabilized weld arcs. At General Electric, Harold V. Kramer refined the AC welding transformer, making portable rigs possible in shipyards across the coast. In Chicago, female instructor Catherine G. Williamson trained over 10,000 welders, men and women, under a crash program funded by the War Manpower Commission. Their efforts turned an untested technique into a nationwide skill. U.S. War Production Board, 1944. By VE Day in May 1945, the results were staggering. More than 5,177 welded merchant ships had been produced, enough to circle the globe if lined end to end. They carried 70% of all Allied cargo during the last 2 years of the war. The welding torch had become as vital as the rifle, the tank, and the bomber. But the story didn't end with victory. The lessons burned into those hulls reshaped every branch of post-war engineering. U.S. Maritime Commission End of War Report, 1945. In the decades that followed, the techniques born in wartime shipyards revolutionized construction worldwide. Welded bridges replaced riveted trusses, skyscrapers rose faster, aircraft became lighter, and pipelines stretched across continents. The very concept of modular assembly, tested first in Kaiser's yards, paved the way for modern aerospace manufacturing and even NASA's launch infrastructure. U.S. Department of Engineering History, 1957. The ridiculous trick had become civilization's backbone, but for the men and women who lived it, the legacy was personal. Many welders returned home with scars and tinnitus from endless hours beside roaring steel. Some suffered from burns, others from exhaustion. Yet, when interviewed years later, almost all said they'd do it again. "We weren't just building ships," recalled welder Sarah Daniels. "We were welding freedom together." Rosie the Riveter Archives, 1978. In their hands, molten metal had become a symbol of endurance, the idea that strength could be shaped by ordinary people under extraordinary pressure. The psychological shift reached the military academies. U.S. Naval constructors began rewriting doctrines around what they called flexible integrity, the ability of a structure to absorb and recover from stress. The philosophy, born from those first welded hulls, would guide design principles through Korea, Vietnam, and into the Gulf War. Every modern destroyer and aircraft carrier owes its skin to that wartime experiment once mocked as foolish. Naval Engineering Symposium Proceedings, 1962. Even the Cold War carried its imprint. The same welding innovations fueled the birth of nuclear submarines, missile silos, and aerospace vehicles. Welding evolved into a science of its own, metallurgy meeting precision physics. The same patterns that once fused victory ships now hold together spacecraft orbiting the Earth. NASA Technical History Report. 70. From shipyards to the stars, the lesson endured. Speed and precision win wars, and ingenuity outpaces fear. Yet among veterans and historians, the emotional resonance remains strongest, not in the machinery, but in the human stories etched into steel. In memorial parks across America, restored victory ships like the SS American Victory and SS Red Oak Victory still rest afloat. Visitors can walk their decks, trace the seamless welds with their fingers, and feel the quiet pride of a generation that refused to slow down. When the light hits the steel just right, the seams gleam faintly, lines of silver that once held the hopes of millions. American Victory Ship Museum Archives. By 1946, the United States had proven something greater than industrial superiority. It had shown that innovation, no matter how absurd or untested, could tip the scales of history when fueled by urgency and faith in the worker's hand. The ridiculous welding trick had done more than build ships. It had built the bridge from the old world of rivets and hammers to the new age of machines and motion. In the final pages of the U.S. Maritime Commission's War Report, a single line captures the spirit of it all. The torch that fused steel together also fused the nation's will. U.S. Maritime Commission, Final report, 1946. The glow of those torches may have dimmed, but their heat remains, in the hulls that survived storms and bombs, and in the story of how laughter turned to awe, and doubt to triumph, because in the end, the war was not won solely by tanks or planes or admirals. It was won by sparks, millions of them, rising from the shipyards of a nation that dared to believe molten metal could win a global war. Dramatized. In modern war, as one engineer later said, speed defeats armor and invention conquers fear.